Hey, I'm Max and welcome to my idle game tutorial. In this tutorial, at the end we should have this result right here, which includes a updating graph that updates every 10 seconds with the new dollars that you have, different coins that you can buy and sell that changes price randomly, and that gives you an interest based on how many you own. So for example, this one I have 22 now, and every 10 seconds it gives me interest based on that and shows in my wallet. For the part 2 of this tutorial, we will create the BigNumber class, which we will use to store big numbers. So go into your scripts folder, create a new C# script and call it something like BigNumber. The BigNumber will actually not be a mono behavior, so we can remove that stuff. So the way I'm going to make a big number is by dividing the number by 1,000 and putting a symbol next to it to represent what it is. So let's say you have 100,000. So what I'll do here is divide by 1,000. So that will give me 100. And then since I divided by 1,000, I would do k for 1,000. Now let's say I have 1,000k, so 1 million. Then I divide by 1,000 too, and I would get 1 and then million. So each time our number reaches 1,000, we divide by 1,000 and then we go to the next letter. And it works the other way around too. Let's say we have 1k and we remove something and we end up with 0.5k. Well, if our number is less than 1, then we do times 1,000 and we go back. So here we'd do 0.5 times 1,000, it would be 500, and then we remove the k, so it's just 500. So into code it would look something like a public float number, and then we could have something like public int index for the symbols, and then we could do something like a private static string array, because we're not going to change the symbols, call it symbols, and then we can set it to nothing for the 0 to 1,000 and then k for 1,000. I'll go up to decillion and it should be fine. Now I will create 3 different constructors for my big numbers. First I'll do a public big number float n, which will be creating a big number from a float. I'll fill it up a little bit later when we have our other functions. Then I'll do a public big number float n and float I for the index, and I'll do number equals to n and index equals to I. And whoops, it's actually int I here, not float. And then we'll do public big number and with another big number, so just to copy one number from the other. And all we have to do is number equals n dot number and index equals n dot index, like this. Then I will add a function to format the number into a string, so we don't have to do it every time. I'll do public string format, and in here I'll just return number to string and then the amount of decimals I want, let's say 2, so f2, and then plus the symbols at the index. So it will be, for example, 1.5k. I will also create a quick void 0 to zero out a big number, so just do number equals 0 and index equals 0. Now let's create a function to add a float amount to our big number. So we'll do public void add float n. The first step is to make sure that the float is on the same power as our big number. So let's say our big number is on the millions. We don't want to add 1 as a float to our number when our number is actually millions. So to do this, we'll do n times equal matf dot pow for power. Then we'll do 0.001, so that's the opposite of times 1,000, which is what we do with our symbol. And then we'll do this for the symbol index, so index. And just put a little f here to say it's a float. So this, for example, if it's 1 and we are at index 1, it will turn into 0.001. Then we'll do number plus equals n. So now that we added a number, we need to make sure that we didn't go over the limit of 1,000. And here I'll do while number is greater or equal to 1,000, number divided equal by 1,000, and index plus plus. So if the number went over 1,000, you divide by 1,000 and add 1 to the index. So let's say we had 999 and then we added 1. Now we're at 1,000, we divide by 1,000, so we have 1, and we add 1 to index, so now we're at k, so we have 1k. And here in our float constructor, we can now do number equals to index equals to 0 and then add n. Now we can do remove, multiply, and divide as well with floats. So since they're very similar, I'm just going to copy and paste and change a few things so that it removes our multiplies instead of adding. So with remove, obviously you need to change plus equal to minus equal. And here, instead of checking if the number is greater than 1000, we have to check if it's less than 1. And if it is, we want to multiply by 1000 and remove one index. So it's really just doing the opposite. Then for multiply, it's also pretty similar. I just don't need this here because multiply doesn't matter what the power of the number is. You know, doing 1 times 2 or 1000 times 2, the number still goes from 1 to 2. So here just have to do number times equal n. And same thing for division. So here I'll do divide. And instead I just divide. And just like removing, I'll check if it's less than 1. I'll do times 1000. And minus minus index. So let's test what we have now and see if it works. I'll go into my player data and set my dollars as a big number instead of a float. And in here I'll do new big number and I'll start at 100. In the update I'll do player data.dollars.add and I'll do, let's say, 100. So since this is called every frame, it should go up very fast. And as you can see, it only displays big number because I didn't call the format string. So here instead of toString, I just have to type format, which is going to call my format function right here. Okay, so it went into the 1000 and 100,000, and let's see if the million works. We're about to hit it, and 1 million. There you go, it's working fine. Now let's push it to the limit and do multiply by 2 and see if it works and how long it's going to work for. Obviously multiply by 2 is going to go up very fast, especially every frame. And there you go. We ended up getting an error at deci because I ended up stopping my symbols at deci right here. So obviously don't multiply every frame because you're going to overload it as well. Okay, so with floats, it's clearly working well, but what if I try to do big number, test equals new big number 100, and I try adding my test here. You can see that doesn't work because we don't have any class to divide a big number by a big number or add a big number with a big number. So we need to do all these operations again, but this time with a big number parameter. That is going to complicate things quite a lot, but we'll try to make it. So instead of doing a function to add, remove, and multiply like we did here, I think it will be better to use operators because then it will be a lot easier to code with them. So the way to make an operator in C# is to do public static big number operator, then space plus parentheses big number n and big number m. So this will be called when we do n plus m. And what we want to do in here is return the result of n plus m. So to do this, I'll create a big number result equals to new big number, and I'll copy the n. I can just put the n in here because of the constructor that we put here. Then I want to calculate the difference in power between the two, so I'll do equals m dot symbol index, so index, minus the result, which is the n dot index. So this right here is going to be the difference in power between n and m. Now I'll do if difference equals to 0, which means they are on the same power. Then I just have to do result dot number plus equal m dot number. Pretty simple. Then I'll do else if difference is greater than 0. So if the second number power is greater than the first number power, in that case what we want to do is take the second number and add the first number into it reduced to the power of the second number. So we'll do result dot number equals m dot number because it's the bigger one plus n dot number, which is the smaller one, times matf dot power 0.001 f to the difference. So let's say the second one is 1000 or 1k and this one is 500, then we'll take 1 for the 1k plus 500 times this, which will reduce it to 0.5. But the result here is the n, which is 500, so the result here doesn't have the k yet. So we have to do result.index equals m.index. And then the last case, else, is the opposite of here. So if first number power is greater than second number power. In that case, we just have to do result.number plus equal m.number times mathf dot power 0.001f difference. But the difference here is the difference between m and n, and here we want the difference between n and m. So we just have to do times equal minus 1. And then at the end we have to do pretty much the same thing as add, so we just do result.number, while result.number is greater than 1000. Then we just do result.number divided equal by 1000 and result.index plus plus, and then we just return the result. Now if we want to try this, we can do, instead of add, we can just do plus equal test, and you can see that using the operator makes it a lot cleaner. And you can see if I run it, it's going to work exactly the same as it did with floats. But now since we're using big numbers, we could do something like player data dollars plus equal new big number, and we could do something huge like one with a bunch of zeros. Actually this might be too big for a float, so instead I'll do 1 and I'll add the index that I want, so let's say 7. And now our dollars should start at a huge amount, and we could not do this with floats. And there you go, you start at 1 sextillion. So now we can try it with the minus instead of the plus. So it's actually the same thing, but instead we do minus here, we do minus here, we do minus here, minus here. Here we do, if it's less than 1, we times equal 1000 and minus minus. Let's test it out and see if it works. Here I'll do equals to big number 13, and I'll do minus equal test and see what that looks like. I'll start it at 10k and see what that looks like. Okay, so I think we will need to add a few cases to make sure we don't loop infinitely, because my Unity just had to be forcibly closed because it was in an infinite loop, and I didn't save my scene, so I lost everything. So let me just remake that and I'll be right back. Okay, so this time I'll be careful to save my scene in case it crashes again. So the reason why it crashed is because I kept removing 100, and then eventually I reached 0. And then when I reach 0, it went, is the number below 1? Yes. Times 1000, 0 times 1000 is 0. Remove an index. Is it below 1? Yes. Times 1000, remove an index. And so it went into an infinite loop. So to make sure that this doesn't happen, I'll do end result.number is greater than 0. And I will also add this to the subtraction up here, just in case, and also the division. But in those two, there is no result, it's just number. So now I will try doing this again and see if it stops at 0. It should not crash anymore. Let's try it out. And there you go, it goes into the negative instead. The negative doesn't really work. I guess you could make something to support it, but in my case I just want the positive. Let's try setting your money to 1 million and then removing 100 per frame and see how that looks, see if it works fine. And yes, that seems to be working fine. So I think that's going to be it for part 2 of the series. The big number was a very big part of the project, and I'm glad that it's working fine. You can keep going to the next episode if they're out when you're watching this. You can also go check out my other Unity tutorials if you want, and subscribe if you like my channel.